Hi, welcome to week 2 of environmental economics. What I'd like to do right at the beginning right now is to say a few words about what we were talking last time so that the subject matter would appear to be, or the material would appear to be related. The first thing that I would like to do is to record these few remarks essentially about the general things that we spoke about last time and chapter 8 before we go into the subject matter of chapter 3, which will be in the next recording after this one. So I guess the question is, what is it that we're really talking about in this course? Let me repeat one more time, and for the last time because of your varied background, that we're really suggesting that we want to look at what is the dynamic that leads to change. This is in essence a philosophical question that has separated two major schools of thought, not only in economics, in practically in politics, in sociology, in practically every field that you can think of. The subject really would require definitely much more than the 15 or 20 minutes, but we have to do with the, given our time limitations, by limiting ourselves to the very few things that I have to say. But one of the most important, some of you might not have heard of it, that's why I'm sort of hesitant, is that we speak quite a lot in environmentalism about something that's called paradigm shift. That's to say, there is a paradigm that is the dominant paradigm right now, call it the mainstream paradigm. It's very often referred to also as being the Newtonian paradigm. So whether you hear about mainstream paradigm, the Newtonian paradigm, or the dominant paradigm, that really encapsulates a certain way of thinking, a greater model of how the world works. How is it that change comes about? How do you understand how history unfolds? Now, contrary to this particular model, there is a model that speaks of paradigm shifts. It says that the paradigm itself, the model itself, must keep on shifting and changing. The mainstream is based on a linear thinking. That's to say, you believe in something, somebody does some research, they add something to it, somebody else in the future adds something to it, and what have you. So it's a cumulative thing. It keeps on accumulating, and you keep on moving upward and becoming, learning more, and that's how change happens. While the other school of thought speaks of a paradigm shift, and the paradigm shift is not linear. It's based on quantum leaps. It is actually saying that your particular vision of reality, of any field whatsoever, will be tested by the signs of the times. When the signs of the times show that your belief does no longer make sense, you don't go ahead and add to the particular model that you are already believing in, but you go ahead and throw it away and start from scratch. The person who started this idea of paradigm shifts, who popularized this model, was a gentleman by the name of Thomas Kuhn, and surprisingly enough, or maybe not surprisingly enough, he was not an environmentalist. That was in the early late 60s, early 70s, where environmentalism was still really in its infant stage, at least in the way that we know it right now. And he was a physicist. So he did this in trying to explain scientific movements. essentially what he said is that, and the words are very important, it's really, there is no substitute for them. As one is articulating a particular vision, any vision, one will run into anomalies at certain times. So when you run into an anomaly, what do? Some people will suggest that you go ahead and throw away the whole model and construct a new model, while others will try to explain the anomaly from within the model. The mainstream people, the current paradigm, the Newtonian paradigm, the dominant paradigm, is the one that tries to explain these anomalies in terms of adjusting the current model. While those who believe in paradigm shift, they simply say that it is our old set of beliefs that created this particular problem that we're dealing with, and so to go ahead and try to fine-tune it will never be a meaningful solution. It will most probably give us some relief, but for a very short period of time. If we really want a meaningful, real solution, then we've got to slough off the old model and adopt a new model. And so, what does this have to do with economics, or with environmental economics in particular? Well, if you still recall from what we suggested last time, and from what has been suggested in your book also, is that the traditional mainstream economists, they really don't believe that there is such a great big crisis in environmentalism. They say, yes, the institutions have failed, so all what we've got to do is to go ahead and modify some of the institutions in order to solve these particular problems. While very many of the environmentalists, and if you still recall in particular the radical environmentalists, they say, no, it is the model that is wrong. It's a systemic problem. So the only way that we can deal with this problem is to go ahead and have a paradigm shift, to adopt a new model. And so here you have it then, that the old traditional economists, they say, okay, all what we know all what we want. All what you have to do is make certain small changes here and there in order to deal with the problems. While on the other hand, you have certain environmentalists that tell you that the only way to deal with the problem is to adopt a completely different model that will ask completely different questions, and therefore we will have to provide completely different answers. They're not asking for a new economic language. As you'll find out, we use the same language. The only question is, what is the question that you ask? The question that you ask is probably more important most of the times than the answer that you give. Because the answers that are given are usually given in response to a question. So if one never asks a question, then one will never have to answer or to provide a particular answer. The most common and the most popular example of a paradigm shift that was used also by Thomas Kuhn in his book, The Theories of a Scientific Revolution, is really what took place as a result of Copernicus and Galileo, around 600 years ago. Prior to Copernicus and Galileo, I hope you all know, for 1200 years prior to Copernicus and Galileo, the only model in the world was that of Ptolemy in this particular case. That's to say, the model was that everything revolves around the planet Earth. But then, when we started looking at the way the stars and the moon and the Earth and the sun move, we found out that these models are not capable of correctly explaining these movements. So you have a model, and right now you have reality, and reality is different from the model. So what did Galileo and Copernicus do? Well, they found out They didn't really add to the previous model. They threw it away. They said the whole model doesn't make sense because everything we revolve around the sun. So we are no longer the center of the universe, the planet Earth. Now, as soon as that changes, it goes without saying, and I don't have really to spend much more time on this, that really changes everything. And actually, some people will believe or will argue very strongly that had it not been for that, then the notion of the scientific revolution and all what has happened and industrialization, they wouldn't have taken place. We had to change our models, our way of thinking, to find out that we are no longer the center of the universe. And so that definitely is one of the best examples. We think that in economics we are exactly at that particular way, especially when it comes to the issue of environment. So we're saying, therefore, that the world is full, and that it's our previous models, the mainstream economic models, if you still remember, that believe in unlimited growth and believe in instrumental value, are the ones that have created the problem that we have right now. And so the environmentalists are saying, well, the first thing that is wrong, therefore, is the fact that we have to change the basis of our model, the circular flow diagram, to show the role of nature, the role of the environment. And then after that, if you still recall, we'll say a few words about the GDP. Before I speak a little bit about this diagram, let me also say a few more words that might be of interest to some of you. It is very widely believed that, by the way, the revolution, the paradigm shift, these quantitative leaps that are required, they occur as a result of the youth. That's to say, you're not going to have somebody who is my age that's going to go ahead and start thinking in revolutionary terms. It is the youth, because they are not wedded to the mainstream thinking. They do not have any vested interest in maintaining the status quo, so they are willing to rock the boat. So if this boat is going to be rocked, and I hope that it would be in the future, it will always come from people that are young. This doesn't mean that you can't have an older person who would come up with new ideas that will rock the boat, that will create a paradigm shift. But in general, that person would have probably shown signs that they are not interested in maintaining the status quo while they're young. And actually, as you probably all will know, starting from Einstein to Newton to Samuelson in economics and Milton Friedman, and whatever, most of them really, they did their work when they were still graduate students. So, there's that very popular idea that many of you have heard, don't trust anybody who's over 30. Well, maybe that's a little bit of an exaggeration, but yes, you shouldn't probably trust anybody who's over 40, because then this idea of their allegiance is going to be to maintain the status quo. But notice right now really the big conflict. If you're saying that the status quo is the problem, then why would you want to maintain it? And that's why really there is a need. Most environmentalists believe, at least serious environmentalists believe, there is a need for a paradigm shift, a completely different way of thinking. Again, in order to be brief, if you still recall, we spoke about this last time, but here just to show it one more time, and I have this diagram, by the way, on Blackboard. As you can see, we're saying that natural resources, are going to lead to production, to consumption, and to utility. So all of this is really something that is positive. So this is the economic activity as we know it. But what we have failed to take into consideration, our traditional mainstream economics, if you still recall the traditional circular flow diagram, is that it doesn't speak anything about renewable resources and exhaustible resources. We have very many resources that are renewable, and we have very many resources that are exhaustible. And there is a limit, even to the renewable, at which rate you can use them. Because even a renewable resource can become an exhaustible resource after a particular period of time. But the other thing that is crucially important about this is the fact that, yes, as you are using the resources for production and for consumption, you're going to be generating waste. And that the first law of thermodynamics is that the overall waste is really the resources that have been used. So really, the waste generated here and here and here add up to total waste that are really over here, that are all of the resources used. And this becomes a hugely important idea, especially if you study some more environmentalism or economics or environmental economics. In the words of one of the most relatively radical, in the sense that he really became a very important environmental economist, Georgescu Roegen. Georgescu Roegen says what's wrong with mainstream economics is that it doesn't recognize that production, the use of resources for production, for consumption, for utility, is eventually what the creation of garbage heaps. That's to say, everything becomes waste. This is what the first law of thermodynamics. It's not a philosophical idea only, it's a true idea. It's the basis of science. Nothing can be created nor destroyed. No matter or energy can ever be created or destroyed. And so all what we do is that we transform them, as we're transforming them into garbage, into waste. Now, the second law of thermodynamics, and both of these really do not show up in the traditional mainstream view of the circular flow, is that part of the waste is going to be recycled. But what is hugely important, again, is that this R is always less than this R. Actually, physically, it cannot be equal to it. No matter what you do, this R is going to be less than this R. There are limitations. But let's just assume, for the sake of the argument, that there are no physical limitations and you can do it. You really wouldn't do it because it will become so expensive to go ahead and recycle the last, let's say, 1% or 1/100th of 1% or 1/1,000,000th of 1%. So there is never, ever complete recycling. Now, what is not recycled is going to be absorbed by the environment. This is the thing. This is the role of the environment. And as we have said, in order to just simplify it again, this is the reason why we weren't that much concerned about environmental activity 200 or 300 years ago, except probably in a philosophical manner. A few philosophers have mentioned it here and there. Outside of that, what we're really saying is that if everything that is going to be produced is going to be within the absorptive capacity of the environment, we're not going to have any problem. But notice, whenever W is greater than the absorptive capacity of the environment, then you have a negative loop. Now, obviously, whatever is going to be less than the absorptive capacity is going to be recycled. So ultimately, what is it that we're talking about, therefore, in environmental economics? We're talking really about the value of this positive loop vis-a-vis the value of this negative loop. What most of the environmental economists and ecological economists obviously are really suggesting is that this negative loop has become larger than the positive loop, at least for the developed countries and obviously for the world as a whole. Had it not been for that, then you wouldn't have a problem in global warming or in the fact that we're running out of fresh water and clean air and what have you. That's to say, the negative disutility as a result of the scale of operation in the world is right now larger than the positive utility that we get out of consuming things that will provide us with a positive utility. Now, I hope that this is relatively clear. I don't want to spend that much more time about it because there are other things that we have to do. But the next thing that I want to just say a few words about, at least as an illustration, because it's really very simple, is that concept of the GDP. If you still recall, the simplest example or the simplest definition of a GDP is that it is the money market value of the final goods and services produced by a society in a particular point in time. But as you can see, it's full really of limitations and that depend on definitions. To start with, you've got to decide whether something is is a final good or service or not, and how is it you're going to go about doing it. You've got to avoid double counting. You've got to decide whether something goes to the market, because you're saying about the market value. So as you can see, one of the first major problems about the dependence on the GDP is the fact that it is very much market oriented. It depends on definition. So if you have two societies that are of the same size, by the way, for exactly the same size, and they produce, let's assume, exactly the same thing, and one of them does it through the market, the other one doesn't do it through the market, which one is going to have a greater GDP? Obviously the one that does it through the market, because it's going to be able to capture a greater proportion of these activities. And so there is a definition, and the point right now that is important is that the GDP, therefore, is not a measure of the quality of life. It is a quantitative measure, and a quantitative measure that depends only on definitions. And economists, by the way, have been critiquing the concept of GDP for a very long time, ever since really it got started. I'm not saying that we don't need the GDP. Actually, no environmentalists will tell you that we don't need the GDP, but we should realize what are its limitations. We shouldn't speak about an improvement in the quality of life only because the GDP and the GDP per capita have improved. As you've noticed, by the way, I have over here GNP, because this refers to a study that was done prior to the United States emphasis on the GDP. The US right now has joined the rest of the world, and we stress GDP instead of GNP. And the difference between them is really relatively minute. I'm not going to bother you with it right now. But one of the most important studies to try to, or examples to try and stress really how much the concept of the GDP really depends on definitions. I played around with the figures recently, and that's why I'm trying to remember them. Let's assume, for the sake of the argument, that you have a society with 10 million households, and the head of each of these households has a housekeeper. Next morning, we wake up and we find out that the 10 million of these households, heads of households, have decided to get married to their housekeeper. Whether he or a she, it makes no difference. What happens to the GDP? If each of these housekeepers was making, let's assume, $100,000, then 10 million times 100,000 is 1 trillion. Then the GDP of that country will go down $1 trillion. So the GDP per capita, depending on the size of the population, would go down also substantially. Does that mean that that society is really worse off? And the answer is hell no. Because nothing has changed. The only thing that has changed is the definition, whether we're going to count that in the GDP, these particular goods and services in the GDP or not. When we were hiring that particular housekeeper, we were paying him or her $100,000. Once they got married to the heads of the household, they were doing exactly the same service. However, they were doing it for free without the market. And as we said last time, there are examples galore, whether it's smoking, whether it's transportation, and what have you. That's to say, what's wrong with the GDP is the fact that it really measures goods and bads. It does not subtract the bads. What most of the environmentalists are suggesting, whether it's the ISEW, which to my mind is the granddaddy of them all, or the GPI or the happiness index, is to make an adjustment to the GDP by adding certain things that should have been added and by subtracting things that should be subtracted. Now, to show you how important this is and how much it changes our concept, look at this. This is for the United States. These are the actual figures of the GNP of the United States. Once you make the adjustment according to the full extent of the definitions done by Cobb and Daly in their book, you will find out that this becomes the ISEW. So as you can see, this is showing that the country really is going nowhere. So we are already at maximum production once you do the adjustment. This one in between is doing some of the adjustment, but not all of them, because some people go ahead and disagree strongly with some of the suggestions. So say, okay, let's not do all the suggestions, do only half of them. But again, you'll find out that the adjusted GDP is lower than the one calculated by the government. And these studies, by the way, have been done, as I said, for Germany, for Italy, for New Zealand, for India, for the UK, for the US, and so on and so forth. And they seem to always lead to this result. That's to say, once you do these same adjustments, you define the adjustments ahead of time, you go ahead and you apply them to any of these countries, and you find out that the adjusted GDP is going, ISEW, is going to be less than the GDP. And so the argument is, in particular for developed countries, we have already reached the top. That's to say, in order to produce that additional unit, the cost of producing that additional unit is going to be greater than the benefit that we derive from that particular unit. That is the major economic explanation used by Daly. Because the more we produce, what the costs increase. We have increasing costs, while benefits decrease, and so you get the greatest benefit from the first unit. So once you get to the millionth unit, the benefit from the millionth unit are going to be tiny, while the costs are going to be huge. And so the answer, therefore, is that why go ahead and produce it. So their argument is, and we go back to a word that we used earlier, and I hope to be able to get to it towards the end of the semester one more time in greater detail, is that there is therefore one solution only. And the solution is to forget about this model of economic growth, economic activity, and economic development, and adopt the model of steady state economics. And this is one more time where the paradigms come in. When one paradigm speaks of instrumental value, the best, by the way, example of an instrumental value is the very popular statement that's attributed to Ronald Reagan when he said something to the effect, if you've seen a red tree, then you've seen them all. That's to say, the value of a red tree, whether it's a million, whether it's 1,000 years old or 1,500 years old, whether it has a diameter of, 50 feet, or whether it's only 2 feet, the only value is the value of the timber. While environmentalists disagree strongly by speaking of the intrinsic value. That's to say, a mountain has a value, a tree has a value, a lion has a value, and so on and so forth. And therefore the values are not going to be determined only by economic utility. Now, I hope that this has given you a better idea about, what shall we call it, the wallpaper that must always be there for the rest of the course. And so the next step is going to be to speak a little bit more in greater details about certain concepts of economics, and that is the market failure. So we do have this market upon which mainstream economics is based, and we're going to argue in greater details that that market fails. It works, but it works only as an abstraction, not in reality, and therefore there is a need to go ahead and change it. So we'll do that in our next clip. Okay? Bye-bye.